Hello and welcome to episode number 8 of Golden Droplets. My name is Ricardo Valls. I'm the founder and principal of Valls Consultant, and I'm also a professional geoscientist registered in the province of Ontario, Canada, with over 36 years of international experience. Today, we are going to start talking about a very important subject, compositional data analysis, which in my opinion should be a subject that should be taught at every university in the world, especially for geologists. And I will begin today showing you an introductory presentation of the subject, and on the next episode I will show you step by step how to process compositional data analysis using a free software called CodaPack that can be downloaded from the internet. All the reference will be in the comments and in the video. So let's go now and see this presentation that was originally intended for Discoveries 2019 in Mexico. Good afternoon and welcome to this presentation. Thank you to Discoveries Mining 2019 to allow me to use this means to do the presentation. I'm sorry I cannot be there with you guys. To obtain a copy of this presentation, including a video explaining each slide, please write me an email at valsvg@gmail.com. My story with compositional data analysis started in 2004 when, on the last day of the 32nd International Geological Congress, I was passing by a room and I saw a sign saying compositional data analysis. Sounded very interesting. I entered and started talking to the people, and as a result, they invited me to their biannual conference, Coda Work 2005. And during a break, I remember everybody was happy talking about compositional closed system, ALR, ELR, permutation. And I said, guys, what about correlations? And there was a silence. And it was like I was yelling pork in the National Assembly of Vegetarians. So one of these guys look at me and say, correlations? That doesn't exist. Correlation is an illusion. I say, who said that? And they say, well, this guy, Carl Pearson, who invented the correlation analysis. And this is really interesting that the guy that wrote and discovered the method advised that there were problems when you were trying to apply correlation to closed system. A closed system is a system where the data has been estimated on the basis of something, let's say part per millions or part per billion percentage. So I say, what? That means that I have been working statistic wrong all the time? And they say, yes, you were. Basically, you cannot do correlation analysis on closed data like geochemical data. If I was another type of person, I will say, okay, you're right, and this will be the shortest presentation on Discoveries 2019. But being a Cuban and very stubborn, I said, no, this cannot be like that. I've been using correlation all my life. So I decided to test their statistic and my statistics. So I created a model, copper mineralization in a porphyritic environment, where the original paper can be downloaded from a Wikipedia. There is a link at the bottom of the slide. So this is how the data looks like. It has not only major element, but also trace elements. And the initial data had 3 conditions. The first one, it was a closed system, meaning that when you sum all the values, you get 100% or close to 100%. There are no zero values present or below the detection limit, just to make this seem simpler. And there are no statistical outliers or hurricane values present. Okay. There were also embedded positive significant correlation between certain elements like copper, arsenicum, nickel, and cobalt, as well as negative significant correlation between other elements like potassium, calcium, silica, aluminum, etc. So according to this embedded condition, any correlation analysis should give me these two set of coefficients: silica versus aluminum, or calcium, sodium, copper, arsenicum versus magnesium, potassium, nickel, and cobalt. So I start by processing the whole data set. Since we don't have zero values or nor statistical analysis, the process was very simple. We determined the distribution log. If we got a log normal distribution, we converted to the logarithmic version. We use Excel to calculate the Pearson correlation, and the critical value of a student was used to determine which of these correlations were significant. So you have here a case of an example of the table of correlation. You notice, for example, in the first column, you have negative correlation between silica and aluminum. That's one thing that we wanted. We put those correlations there. So they're there. So when making my range correlation coefficient, I'm sorry I cannot be there to explain you in detail how do we get this coefficient, but basically any element that is next to another one, they are directly correlated. Any element that is on top of the other one are inverse correlated. So in this case, for example, aluminum is directly correlated to iron, but aluminum is inversely correlated to silica. Okay, so these were the two correlations that I got. If you look at this in detail, you can see my original correlation are there, but there are also a lot of what is called spurious correlations that they don't exist, but mathematically we got them. One of the best examples is the silica titanium, as you can see here in the graphic, is not existent. So when I try to make the map of the RCC1, this is what I got. And let me get the laser pointer. So if I was a geochemist and I send this map to my boss and I say, well, we need to drill, you're probably going to be drilling here, here, well, here too, here, here. Maybe you will go out of your here. So of the 4 holes that you will be probably drilling, only 1 or 2 will be close to the anomaly. So that's the current situation. That is why you use correlation and you get some results, okay? Because you get some, but you don't get the full picture. And this was our best RCC. Okay, not very good. But I said to myself, well, maybe because I'm mixing the major elements with the trace elements. So let's separate them. Okay? And no cigar. We got almost the same result, just better structure. Okay, in this case, we probably will be drilling here, but we also will be drilling here and we'll be drilling here. So it's like a 1 in 3 cases to get the actual anomaly. So yes, regrettably, it is clear that closed system provokes spurious correlation. And it's especially true when you're trying to combine major oxide with trace elements. So a better solution will be to separate those group majors from oxide, but there are clear disadvantages of doing that. Okay, so my statistics is not good enough. What about theirs? Because, okay, I'm very stubborn. So as I mentioned, CODA-PAC uses 3 algorithms, ILR, CLR, and ILR, to transform your data from a closed system to an open system. This is an example of using one of the algorithms, the CLR, and as you can see, the sum now of all the elements is 0, not 100. Once you convert the data to an open system, you can come back and use your normal Excel or SysStat, etc. CODA-PAC allows you to do a statistic within the simplex, within the CODA-PAC system. But you can, go back and use your normal Excel. So this is the coefficient that I obtained. And here is how we look in the map. As you can see, a much better result. First of all, the structure is much better, and we are concentrating right in the mineralized zone. So this map is really good. Now, if we only use the strongest correlation, like above 0.95, then we get these two coefficients, and the map is almost a perfect, correspond almost perfectly with the ore body. That is very good. Now, as I mentioned, they have other algorithms, the ALR and the ILR. The ILR, that's the coefficient, that's the map. Again, almost a perfect match. And the ILR, which is the best, a little bit more complex, that is your result. As you can see, you are really, really concentrating on the center of the anomaly. So, some conclusion of their statistics is we get rid of the spurious correlation. The correlation we have are the real ones. We can process the whole data, measures and trace elements together, not a problem. There is no need for testing for statistical outliers or distribution loss. And one of the most important ones, you can now believe in your geochemical maps, which is something very, very useful and important. Now, wait a second. There are other statistical methods like FAR assay factor analysis or principal component analysis. So how do they do? I apply factor analysis to the raw data and to the IRL transform data, and we get maps. As you can see, factor analysis works very well too, but the problem with factor analysis is that you need to know what each factor represents. So it requires a much better understanding of the geology, or a test this, and see which one gives you a better result. Again, the factor analysis applied to a ILR gave a much better distribution of the anomaly. So, and the winner is if you want to keep using your old way of processing, your old system, please use only the strongest correlation. That way, at least you're going to minimize the chance of having a spurious correlation within your data. And do not mix trace element with major oxides, because that doesn't help. Of course, factor analysis is a very good method when you can use them combining with your brain. But if you really want to get all the information from your data, make sure that there are no spurious correlation. Not worry about distribution law or statistical outliers. Then welcome to the CODA family. Thank you for your attention. As I mentioned before, the original paper can be consulted and edited at Wikibooks. That's the link there. And I also want to mention, since I'm here, this book is called Exploring Geological Data with WECA, CODAPAC, and INSIGHT, which is a step-by-step graphical guide, not only of how to use compositional data analysis, but also how to use artificial intelligence in the processing of your data. And thank you very much for your attention. Thank you to Discoveries for allowing me to present this way. Have a great day.
Welcome back. So I hope this presentation show you the importance, actually the necessity of applying compositional data analysis when you're processing data, especially geochemical data. As I told you at the beginning, next episode I will show you how I do this thing using CODAPAC and also Excel. Please remember to subscribe, and until next Golden Drop episode, have a nice day.